Hi there. Welcome to this tutorial. In this tutorial, we're going to explore how to integrate Dynamo and Viktor to create scalable web applications. So if you're a computational designer, you already have Dynamo skills and you already know how to program in Python, we can combine these skills to create applications that can be shared with many other people in the world and people in your office. So the prerequisite, as I've mentioned, is to have working knowledge of Dynamo and also Python. With Viktor and Dynamo, you can build applications similar to this one, which I've built to automate parking layouts. People have found it to be very useful, and yeah, it's a great thing to be able to do. So this tutorial in a lot of detail will cover installing Viktor on your computer, installing and configuring the VIKTOR Worker, and also we will build a sample application using the sample Dynamo script provided in this tutorial to build an application, and then we will publish it on the Viktor platform. So if you like this video, please make sure you like and subscribe to the channel. It helps us a lot. And if you have any comments, something you don't like and anything you like, please do add to the comments as well. Thank you for watching and enjoy the tutorial. Cheers. Hi there. So the first thing to do is install Python if you don't have Python installed on your computer already. So I literally just searched for Python download and I got python.org, download Python as the first item. So just click on that and then just click on this download Python 3.1, 2.2. And there we go. Download it, and now let's go through the installation process. Awesome. So now let's install Python. Head over to your downloads folder and click on the executable file. And one important thing to do here is to tick the add python.exe to path. This just makes sure your system automatically knows what path to head to run Python. All right. So click on install now. Let's do that. And this installation shouldn't take too long. Perfect. That took about 3 minutes to install. And now Python is all set up, and we can just close this. And now your computer can run Python scripts and is ready for the rest of the Viktor installation. So now to begin the process of installing the Viktor SDK on your system, you first have to create an account. So head over to viktor.ai, viktor.ai, and head over here to sign in. Then free account and sign up. And now type in your details and then you hit submit. And then over here, they ask you some information about your industry. So just click on everything that applies to you and then hit get started. And then verify you're not a robot. And then you get this welcome to Viktor page, and then go check your email for the confirmation email. Email basically where you need to verify your account. All right, you should have received an email from Viktor, and in that email, there should be an activate your account button. So just click on that. And once it's verified, you should get this pop up. And now we can begin the installation process. All right, now let's start the Software Development Kit SDK installation process. So to install Viktor, you have two options: to either install it on a cloud-based environment, which is GitHub Codespaces, or you can install locally on your computer. But first, let's discuss the first option, although this tutorial is focused on installing locally on your computer. All right, so let's take a look at GitHub Codespaces. So this here is. Let me just scroll right to the bottom for the pricing. All right, so I basically worked out that for 2 cores, after the 60 free hours, let's assume you were coding the whole month consistently, which probably wouldn't be the case. I would have to personally have to pay about 2,000 Rand, or which is equivalent to about $120. But it might actually be half that if you don't code as much. But as you go higher, obviously to up to 16 cores, the price becomes a lot more, right? And you also have to pay for storage. So if you have a serious development team, you have a company that has enough budget, go ahead. I'm sure this will be a much more flexible option. But for me, I would have to just go ahead with my local installation. So let's take a look at how that works. So now let's start the download process on our computers. So click on this "I want to develop locally on my computer" button. Okay, so it's asking, do you have Python? So we did install Python previously, so we can click here, I have Python. And then now let's download Viktor. So here we have to select our operating system. So here, click on Windows. That's my operating system. So if you have other operating systems, please choose them. And then click on Download. Great. So now the executable file to install Viktor has been downloaded. So now let's go take a look and install it. Perfect. Okay. Now head over to your Downloads folder and double click on the VIKTOR CLI installer. Okay. And now click Next. Accept terms in the license agreement, and Next, and Next, and then Install. Right, so that was pretty quick, and then hit Finish. So now let's head back to the Viktor website to continue the process. So now that we've run the Viktor executable on our computers, let's hit Next. So it's basically telling us to do what we've just done, which is the installation. So we can just hit here. I have installed Viktor. So now the next thing to do is to actually activate our account. So on our computer, we need to open Windows PowerShell and then run this command in PowerShell. So you can just literally copy and paste this using this button over here. And then the PowerShell is going to give us an activation code, which we will then type in here. All right. So let's take a look at that. Copy the command on the Viktor website that was mentioned previously and paste it over here and then hit enter. And then now you're greeted with this, welcome to Viktor. And right at the bottom, we have the code. So copy that. And now let's head back to the website. So paste that 6-digit code and then hit activate. Okay. And then now our account has been activated and then a demo app basically loads. This demo app is going to just help us confirm that our installation is working correctly. So let me just open PowerShell again. Okay. And as you can see, some things are happening on PowerShell. So all the libraries, as I can see here, required to run Viktor, and all the Viktor libraries, any external library required has basically been installed. So once that is done, we have to return to our browser to continue the installation process. Okay, so once that is completed, you can see here that a demo app has shown up. So basically, means our Viktor installation is working. So now we can see the default app. That's basically, it's essentially running off your computer. And yeah, it is working. So let's just go through all these steps over here. Okay, perfect. That is working. So let me actually just put this and this side by side. So as you can see, once you've changed something, it's basically talking to your computer. All right. If I go to the next step as well. So we've basically confirmed now that everything is working as it should. We're not done because we're not just building on Viktor. we want to connect Dynamo to Viktor so we can host a Dynamo workflow on the platform. So the next step for us to do is to see how we can install the VIKTOR Worker. All right, let's go on to the next step. Thank you. Hi there. Before we actually install the VIKTOR Worker, I think it's important to illustrate what the worker actually does. So take, for instance, you have your VIKTOR app on the front end and the Dynamo application, Dynamo Sandbox, installed on a server on premise in your office or on a cloud service like Amazon or IBM or any other cloud service provider. So what happens is the worker basically takes the Dynamo script, which has been configured, moves it across to the Dynamo application at the back end, initiates the Dynamo CLI to make those changes, to run all those configurations that your users have made on your front end, and it takes that it takes the outputs, which is the geometry.json file and the XML file, across to the front-end application. This happens over and over and over as required by yourself or your users. I hope that clarifies it, makes it a little more understandable. Thank you. Hi there. Before we install the worker, let us download Dynamo Sandbox and Autodesk Formit. These two pieces of software will be important for us to actually create a backend Dynamo app that transmits information to the VIKTOR app through the worker. All right, so I've already downloaded the 3.03, so I don't need to do that again. So just download that and unzip it with 7-zip, or if you're going to use your system's default unzipper, make sure you right-click on the file and unblock it in the properties. Hi there. Now let's extract the contents of our Dynamo Core runtime zip file. All right, so you right-click on it and head to properties and make sure you unblock the file and then say OK. And this is if you do not have 7-zip. All right, if you have 7-zip, it does that automatically. So now we can right-click on it again and then say extract all, and then just say extract, and then let the extraction process complete. So now once that's done, copy the extracted file to a folder in your C drive under your username. So let's go to my C drive. So what I've done is under users and then my username, I've made a folder here called VIKTOR Worker, and then I just pasted the sandbox file in, and I then renamed it to Dynamo Sandbox. This will make sense in the next part. So the reason we need Dynamo Sandbox and not just use the former installation on its own is that on my previous installation, I found the Formit installation to be faulty, right? So the sandbox inside the Formit installation is faulty. So we're just going to use this as a workaround to make sure it works. All right, let's go on to the next step. Thank you. Now let's head over to formit.autodesk.com, link in description, to download Autodesk Formit. The reason we need Autodesk Formit is because of its ASM geometry library. So basically the worker and the Dynamo CLI will call upon that geometry library to process the geometry that's in Dynamo, and then that file is going to be taken onto the VIKTOR environment for display on your app. All right, so let's hit download. Okay, then you can either download Formit for Windows or Formit for iPad, Formit for web, but we need, in my case, I'll need Formit for Windows, and I'm sure in your case as well. So just click on that download button and bring it onto your system. Great. So before we go about installing the worker on our systems, let us install Autodesk Formit. So double click on the install file we downloaded. Okay, and now extract the contents. So this might take a while, so feel free to pause the video as you go through the installation process. Okay, agree to the terms of use and hit next, and then install. As long as you're fine with it installing in your C drive, and then yes. Great, so the installation is done. And then we can just start Formit, just make sure it's working. Great. As one final step before we install the worker, let us just make sure that our Dynamo Sandbox and our Formit installation are working correctly. To do that, we will use the Dynamo CLI. So download the sample files in the description. If you do not want to do the step, feel free to skip along in the video. So what I'm going to do here is, so you should have these two files in the sample files. So this input Dynamo file is what we're going to actually publish on our app, just to test out the VIKTOR environment. But before that, let's just output the geometry and the XML file. Let us just get this command, open this command file. I'm going to double click on it. And over here, this line here is basically the command we're going to run in the Dynamo CLI. So over here, you can see the path to the Dynamo CLI, users, then your username. So just change your username here. So based on your path. So mine, I'm going to change as well. And then VIKTOR Worker, Sandbox, so basically that, then the Dynamo CLI. So this over here says open this Dynamo file, which is this Dynamo file. And this is for the output XML file from the Dynamo file. Then the geometry path is the geometry library in our Formit installation. Okay, just make sure that's correct. And then G means here is that it should output a file called geometry.json. Okay, so it's this geometry.json that will be displayed in the VIKTOR app. Okay, so I'm just going to change this over here to my username. Okay, then I'm going to copy this. Then go over here and type in CMD, which is for command. It's for the command prompt to show up. Then I'll paste this over here. Right? Then hit enter. If this is working correctly, we should get an output geometry.json file and an XML file. As you can see, it is working correctly. So we got the output. So I'm just going to double click on this as well. As you can see here, this is the XML file that contains all the outputs from our Dynamo file and also the geometry.json file. As you can see here, that is basically the output. Right, so from that, if you have that, we can confirm that it's working correctly. Now let's install the VIKTOR Worker. All right, so head over to the VIKTOR Docs, link in description. So that's docs.viktor.ai. And then on this left panel, click on this arrow, which is close to Manage Apps. And then look here for workers. And then this page basically gives you a detailed description about how to set up a worker and what a worker is about. So have a read. Okay. Well, let's just head right back up. And then you just tick here, accept terms and conditions. For Dynamo, the Dynamo integration, we only need the generic worker. So as you can see here, there are other workers for other applications such as Excel, Grasshopper, and other engineering applications. All right, so we're just going to choose the generic one and then say download installer. To install the VIKTOR Worker on your computer, head over to your download folder or wherever you saved the installer. Double click on the installer and then run the program if there's any block by your computer. All right, then hit next. Accept the terms in the license agreement. And just make sure you haven't installed any version of the worker before and tick that checkbox and hit next. And allow a shortcut on your desktop. I recommend that. And hit next and next. And here we have to go get credentials from your VIKTOR workspace. And we're going to place those credentials in here. So let's take a look at how that would work. In your VIKTOR workspace, to create a new worker, head over to Workers. And then over here at the top right, say Create Worker. And then just give the worker a description. So I'll just call mine Dynamo Worker. And then the integration type is going to be generic. And then the assignment I'm going to leave as global. So when you have a lot of apps, you might want your worker to be dedicated to one particular app. So you can say specific, and then you're dedicated to a particular workspace, I mean. All right. But I just want this to be global, which means if I have a few apps, they can all use this worker. But this can also be edited later. And you say create. All right. When you've created the worker, an identifier comes up. Make sure no one can see that identifier. And then at the bottom, also the credentials, also make sure that is kept very secret. So these are very confidential. This is confidential information. So I'm going to hide mine. So just, yeah, do not let that information go out of your office or let anyone see it, because that will be a security risk. All right, so I'm going to copy the credentials right at the bottom. Okay. Or you can hit copy to clipboard. And then I'll head back to the VIKTOR, to the worker installation, and then paste it. All right. And then say next. And then make sure create scheduled task is ticked. What this means is that once your computer is restarted, the worker automatically starts up. So you do not have to start the worker manually, right? Because you might forget to do so and run your VIKTOR app, and you'll be surprised that the application is not running, right? So just make sure that you create a scheduled task. Then hit next, and then hit install. All right, and you can see that was finished. Right, and then it says you must restart your system for it to take full effect. So let's restart our system and then fully configure the worker. Awesome. Now let's configure the worker. In your VIKTOR workspace, head over to Workers, and the worker we created previously will be here, the generic worker. And as you can see here under status, it says offline. So once we've configured the worker on our computers, we should have a green indicator over here showing that it's working correctly. All right. So now head over in the description in the sample files, download the config file. All right. And then in your downloads folder, once it's downloaded, just double click on it to open it in your text editor or your Visual Studio Code or whatever other text editor you have. All right. So now double click on it. All right. And in here, you don't have to worry too much about the text in green. What we have to be concerned about is this, the executables, all the way to the bottom. All right, so this basically mirrors the command we entered previously in the command prompt to test out if our installations for the Dynamo Sandbox and Formit were working correctly. So basically this path shows where the Dynamo CLI is. So at the moment, I've configured it for my computer. So you can see here, my C drive users and my username. So just change this here to your username, okay? And then make sure the VIKTOR Worker folder that has the Dynamo Sandbox in it is spelled correctly. If it has caps, make sure you include caps. If it's all small letters, make sure it's small letters. Check the path to make sure it's as shown on your system. And the arguments are the same like previous. So this to basically open, this O is to open the input Dynamo file. This here is to create for creating the output XML file, and the geometry path, which is in our Formit installation. And this is just telling it as well to output a geometry.json file. Then the working directory path basically means where the worker will be outputting all these files into, as you saw previously, because we ran the command in that VIKTOR Worker file, it outputted the XML file and the geometry.json file into our directory path. So the worker will basically be using that folder as the location to dump all that information. And max parallel processes, you just leave as one. But in the situation where you want to actually start scaling your applications to pushing it to multiple users, you can then change this to as many as you require. But obviously consult with your infrastructure provider. Maybe it's IBM Cloud or Amazon Cloud, or if it's an on-premise server, consult with your IT company just to make sure that the max amount of parallel processes you've allowed for will actually work. I know it does comment here that it must be one, but I've tested it and it does work. I've worked with a situation where there are 10 parallel processes and they were working fine. You just need to have enough compute to support it. All right, so this is basically all set up for me. Make sure your username here and here are correct. If you've used the settings as I showed previously, everything should work correctly. All right, so I'm just going to save this again and then close this. All right, now copy this file, the config file, Control-C, then head over to your C drive and then Program Files, and then VIKTOR. And then here you can see the worker we installed, and this is the config file we must replace. So just paste and then say replace file in destination, and it's going to need your permission, the administrator permission. So make sure you have administrator privileges to be able to make this change. Okay, so hit continue. Okay, now we've replaced it, and now we just need to test that the worker is working correctly. To confirm that the VIKTOR Worker is working correctly, right-click on this VIKTOR Worker generic application and run as administrator. And then you should get this command prompt, and at the bottom of it, it should say successfully connected to the server. If you do not get this message, it means your configuration has most likely not been done correctly. All right, and also note that you wouldn't have to start it up manually like this if you also installed it as a scheduled task. So if you do not, if you want to then do it as a scheduled task after the fact, check the link in the description for an article that describes how to create a scheduled task on your computer. All right, let's actually take a look at the VIKTOR workspace on the VIKTOR platform to see if the worker icon is showing green, which means that it's also working on that end. To confirm if your worker has been registered in your VIKTOR workspace and is working correctly, head over to the administrator section and click on workers. And then now, when you look at the status column, you should see a green tick that indicates that the worker is available. So now the process of installing the worker is complete. Let's go on to actually create a Dynamo workflow and integrate it into VIKTOR. See you at the next section. Thank you. Before we integrate our Dynamo script into a VIKTOR application, let's first of all take a look at the workflow. Okay, so make sure you have a copy of the Dynamo Sandbox in your downloads, or you can also open the one you've stored in your C drive under your username. All right, so just double click on the folder and then right click on this Dynamo Sandbox icon over here. You can also create a shortcut for your desktop and create shortcut. So you don't have to do this coming to this folder over and over, right? So just right click on this and then just note that you need a license to a Revit license or an Autodesk license. I'm not sure what other licenses you would need to work with, but if you have an Autodesk AC license or Revit license, the sandbox will work. All right, so launch Dynamo. Here we go, and then open the workflow. So from the sample files that you've downloaded, link in description, open the input Dynamo file, and then just set the run to automatic. I'm not going to go through the scripting because this tutorial is not about Dynamo scripting, but I'm just going to explain what we'll be working on. So here we have about 8 inputs. We're going to basically, in our Python script, call on all these inputs, right? And link them into the workflow. So VIKTOR will basically then be able to change all these, and when the script is sent to the backend and run in the CLI, we get the geometry and or any other outputs. So basically we'll be able to change the rotation, as you can see here. We'll be able to change the number of floors and the floor heights, the width, and other parameters like the z-axis and the length. Yeah, so this is what we'll be integrating. It's a very short workflow, and yeah, let us go ahead. Now let's create your first VIKTOR app. To start the process, in your C drive under your username, create a folder called VIKTOR-apps in small letters. VIKTOR-apps. And then within that folder, so basically all your app folders you can store here. It's recommended that you store all your apps in the C drive. And so create a folder here called test Dynamo app. You can call it whatever you want, but for this, just so there are no errors later on, just let's keep it the same. Test Dynamo app. So we will then install the app in this folder. Let's take a look at how to do that. To start the app installation process, head over to your text editor. A text editor such as this one, Visual Studio Code or PyCharm, or any other text editor you have installed on your system. If you want to install Visual Studio Code, check the link in the description. I've included the download link. All right, so let's head over to the folder, to the app folder we just made. Head over to File, then Open Folder, and then head over into your VIKTOR apps, and then select the Test Dynamo app folder, and then at the bottom right hand corner select folder. All right, Now we need to enter a few commands in the terminal. So now go to View, then open the terminal, and then in the terminal, let's type in VIKTOR CLI space create app app and then space app type, then space editor. VIKTOR CLI create app type editor, then push enter. As you can see here, it says successfully created app in the current working directory. And when you look over here now, there are now new files created under that folder. All right. So the next thing to do is to install the app. All right. So in the terminal, type in VIKTOR CLI install. VIKTOR CLI install, and then hit enter. So what's happening now? It's creating a virtual environment, and it's going to be adding any libraries required for the app to function. And this might take a while, so feel free to pause the video while this happens. Now, when that's done, you can see here the application has successfully been installed, and we can start our app using the command VIKTOR CLI start. Okay, next, let's start the app. To start your VIKTOR app, let's head to the terminal. But firstly, let me close this Explorer panel on VS Code. All right, by clicking the button over here at the top right corner. And then firstly, let's type the command VIKTOR CLI clear. This just makes sure that any entities, essentially any obstructions from previous apps, get removed. But this is probably your first app, so you do not necessarily have to worry about that. So now to start the app, let's type in VIKTOR CLI start. Okay, now you'll see a few lines of text, and at the bottom, if the app is working as expected, you should get the message app is ready. Sometimes you won't get that message if the code in your app.py file or any setup in your file is incorrect, in your app is incorrect. But this is an empty app, so everything is working well, so we've gotten this message. To close the connection between the VIKTOR Cloud and your application, you can type in Ctrl+C. All right, so now in your VIKTOR workspace, as you can see on my left, and the left panel on my screen, head over to this development icon over here and click open. So this is basically the environment where you'll be able to see what the app looks like before you actually publish the app. As you can see here, this is empty, so we do not have, because we do not have any inputs, any views set up. It's just a clean app. And just to note, like I mentioned, this will be an editor type app because it's a free version. We haven't made any payments for a simple type app or tree type app, which you can also read about in the VIKTOR documentation. All right, let's head back to the Explorer panel over here and click on this app.py file. And I'll close the Explorer panel again. So let me explain the parts of this app.py. So it's in this file that you'll type up any code that's required for your app to function. And as we type in parameters and other items, they'll start getting visible in our app. So to explain this, at the top is the boilerplate code, which is basically where you import any VIKTOR libraries or any external libraries required for your app to function. All right, and over here we have the parameterization class, If you do not understand object-oriented programming, I advise you take a Python course to help you understand this, or you can read the Dynamo Python primer, which has a good explanation on classes, methods, attributes, enumerators, and other items you need to understand for this programming. But essentially, the parameterization class is where you add all the parameters for user input. So for instance, parameters such as text, it could be static text as well, just to help the user understand what to do in the app, parameters to add points, parameters to add numbers, parameters for tables, and all sorts of other parameters available on the Viktor platform. The controller class, as described, is the controller that basically it essentially controls your app. It determines what the user will end up seeing on the application. It is the engine of the app. All right, next, let's add a few inputs by looking through the VIKTOR Docs. Thank you. To add a few parameters to our app, let's head over to the VIKTOR Docs. So those parameters we will be adding in the parameterization class. So let's see what it takes to add about 3 parameters to this parameterization class. Remember that our app is actually still empty, so it's actually not doing anything at the moment. So for the VIKTOR Docs, head to docs.viktor.ai, link in description, and then when you get to the landing page, click over here on this icon with the 3 lines. Then here you can see the getting started. So with the installation, how to create your first app. So essentially the process we're going through. And then over here, create apps has very important information. And here, fundamentals. And it also talks through the app types. So we're using an editor type app at the moment. So this is the free version. And in the paid versions, you then get to create simple type apps and tree type apps. For us, what's important is this, and we'll also be using a few of these as well. Okay, so here under user input, let's see how to create a number field. Okay, numeric input. So click here, numeric input, and then it opens up the description of the number field. So as you can see here in the boilerplate code, we need to make modifications to this boilerplate code we have in our Python script. So over here, we need to add a comma and add a number field. So head back to your app.py Python file and type in number field. Okay. And then in the parameterization class, remove this pass and then type in here number equals. So the number is the variable, and then now add the number field class and then type in here this is a number. Okay, so this obviously is the description of the parameter. If you hover over the number field in VS Code, you can see the other arguments we can add. We'll take a look at some of these later on. Okay, so now to make this take effect in your app, hit Ctrl S to save the app. And if we've done this correctly, it should say app is ready again. So head back to the left side and go to your VIKTOR app and then refresh. And as you can see here, this is a number, gets added over there. And now we can type in a number if we wanted, as you can see. Okay, so Let's add another parameter. Hit enter, and let's look at what it will take to add a text parameter. So head back to the docs, click on these 3 lines again, and then look for textual input. All right. So as you can see here in the parameterization again, in the boilerplate again, we need to add a text field. So at the end, add a comma, and then say text field. Head back, and then type in text field, and then let's type in here, this is text, and then save it, and then head back to your Viktor app, refresh. As you can see there, it says this is text. Sometimes you might not want your inputs to be on the same line. So there's another thing you can add to your boilerplate called a line break. And then you hit enter over here, and you just type in a variable that says line break, and then say equals line break, and add parentheses to the end, and then hit save. And then when you refresh, as you can see there, now the inputs have been arranged in order on top of each other. Let's add one more parameter. So let's head back into the docs, click on those lines again, and then let's say we want to add let's say add a map feature. Okay, so for instance, let's add a point field. So this will basically allow a user to add a point on a map. So let's head over here again, comma, geo point field. Okay, and for this we can add another line break, copy and paste, and then enter, type in geo_point. Of course, your variables don't have to be the same as the docs. I'm just making it clear. And then here type in geopoint field, and in brackets we can say add a point, and then hit save. Oh, as you can see here, we didn't close this, so it gave us an error. So close that and then hit save, and then head back to the app, refresh. As you can see there, now we have a geopoint field that's also been arranged vertically. Okay, so now let's take a few other arguments within the number field. Let's see what we can do to change the way the number field behaves. Let's say we want to make this number field a lot longer. So what we can do there is look into the flex option. You see there, flex. I'm just going to hit enter over here. Okay, and then also hit enter here, and backspace. Then add a comma here and type in flex, and then say equals 100, and then hit save again. And then when we refresh this, our number field should be as long as our parameterization. So when you say 100, it means you want your parameter to be as 100%, to take up 100% of the parameterization space. If we drop that to about 75, we hit save again, you will see now that the number field has been reduced by 25%. Okay, let's take a look at a few other arguments available in the number field. For instance, we can change the number field using this variant argument to a number slider. So add a comma after flex and then say variant, and then add a string that says slider. Okay. And then hit save. Okay, there's an error somewhere. Okay, so for the slider variant, we need to define min and max for the number field. All right, so type in another argument called min. And then let's make the minimum 0. And then let's make the maximum with max. The max argument, let's make the max 100. Okay, and now hit save again. Okay, and then refresh. As you can see now, our slider, our number field is now a slider. So we can now slide it instead of typing from 0 to 100. We can also add a default value if we hit a comma here and type in default. And we can say, for instance, 20. And then hit save again. And let's head back to our editor, refresh, and then as you can see here, it now has a default value of 20, and it indicates here that this indicates the position of 20 over here. The same thing can be done to this text field. We can add a flex, hit enter over here, and hit enter, and move this back and add a comma and then type in default and then give this a value text input and then hit save and head back again to our editor. As you can see there, we have a default value of text input. So this is just basics of, grabbing the information you need from the docs and applying it to your app. In the next section, which is the actual Dynamo scripting, we will do some more advanced, add some more parameters, and also add views for PDF and image, and then also the 3D view for the Dynamo workflow. We're almost done. See you in the next part. Thank you. Hi there. Now let's configure our Python script so it can pick up on these parameters available in Dynamo. So we will leave these first three out, X, Y, and Z. The reason for that is that the geometry that's actually brought into Viktor is automatically projected from what I noticed, it's automatically projected to the center axis of the 3D model space. So we won't need to change that position. So let's just leave that as is. So we will take these 6 parameters, the width, length, floor height, floor count, rotation, and geometry color, and add those into the parameterization. So undo what we did previously with the number fields and all the other changes we made, and just have the default code that comes with the installation. All right, if you have saved this already, what you can do is head into the sample files and take the app_start file and copy and paste the code into this file. Please do not replace your app.py file with that app_start because the naming is important. It has to be app.py. All right, so you can replace it if you rename the app_start to app.py. That would work as well. Okay, so the first thing we need to do here is to, I'm just going to close this. We need to then add a number field class again. So we need to load that from the Viktor parameterization. So add a comma and type in number field. Okay, and then here, like we did previously, remove the pass and then type here building underscore width and equals number field and in brackets I will say building width. Building width. There we go. So obviously we're still going to modify this further, but let's just make sure that it's working and by connecting to the Viktor server. Okay, so type in here Viktor-CLI start and hit enter. There we go. So the app is ready. So now we can just head back to the Viktor cloud. Okay. Click in your environment, your workspace. Click here on development environment to open. Okay. And as you can see here, we've got our building width parameter. So let's make further modifications to this. All right. So hit enter. Okay, and hit enter again, and then let that bracket line up with the variable. Then add a comma, and then let's add a description to this parameter. Okay, so that's the description argument, and then let's add a string with quotes. Then I'll say here the width of the building. And add a comma. Now let's add a minimum value for the building width, because obviously we won't want our building to be less than a certain value, because we know if the building width is 0 in Dynamo, that will lead to an error. So let's make sure the user can't enter a value less than 1. So we'll say min is equals to 1, max is equals to, you can make these values what you want, but I'm going to go for 1 and 20. And add another comma, and then we can also add a step. Step, I will say is equal to 1, and then a suffix. I'm going to give it the suffix has to be a string, so this is in meters, so I'm giving it the meters symbol, and then a default value. I will make 5. So that's 5 meters. And the flex for this parameter, I would like to be 100. So it takes up the whole width of the parameterization. Okay. Now let's hit save. And if everything was entered correctly, we should get app is ready. Okay, now head back to your environment and refresh. And as you can see now, we've got a building width of 5 as the default. And now we also have a description there that says width of the building, as you can see there. And yeah, now let's do the same thing for the other parameters. So just repeat what we just did here. So as you can see, length, flow height, flow count, rotation, and then I'll show you how to add the color. All right, so let's do that. So if you do not want to do this yourself, you can just head to the app_end file, the Python file, and you can just copy and paste the code. So let's do this and see you at the geometry color and when we're adding that parameter. Okay, there we go. So now we've added all those parameters. So we've added number field, we've instantiated the number field class for the building width and for the building length, the floor height, the floor count, you can see there, the rotation, that rotation, and the last one we need to do is the color. Okay, so let's take a look to see if it's working correctly in the environment. So head back to your browser, refresh. As you can see there, we have all those parameters linked in. So we've got 3 sliders and we've got 2 fixed fields over there, just the standard number fields. Okay, so now let's take a look at how to add a color field. So for this, let's head over to the VIKTOR documentation. Okay, and click on these 3 lines at the top left corner and head over to create apps, and here user inputs, and then now let's search over here. Okay, so that has to be under other fields, and as you can see here, we've got the color field. So in the parameterization, we need to add this color field. So head back up, and then in a comma, add color field, and also add color. Okay, so we've added the color field class and also the color class. Let's take a look at how to add it to our parameterization. So now I'm going to create a variable called geocolor for geometry color, and then equal, and now instantiate the color field class and add a comma and hit enter. And then now type in the description saying select a color, and now let's hit save just to make sure it's working correctly, and then head back to our environment and hit refresh. As you can see, now we have a color field over there, and if we click on it, we can now choose a color, whatever color we want. But we want that to be a default color. We want to be able to set a default color for that as well. So for that, I'm going to use the computational design essay color, but let's first add a comma and add a description over here. Description, and then I'll prompt the user by saying select the color for the geometry. Perfect. Add a comma, hit enter, and now the default color. To do this, we need to instantiate the color class we pulled in our boilerplate code, that one. Right, and type in color and add brackets. Now the color expects integers indicating the R, G, and B values of your color. Okay, so the color value is 16139. Feel free to choose a color you prefer, and then 163. And comma flex is equals to 100. Right, then hit save, and the app is ready. And head to your browser and hit the refresh button, reload. And as you can see, the color has been changed to the default color we've provided. Okay, let's make further modifications to the parameterization to add an image and to add a description to the parameters. All right, so let's hit enter from the semicolon, and let's just give our parameterization class a description. Okay, using docstring. Sorry, excuse me. Okay, so I'm just going to call this a class to add user inputs. Okay, and when I hover over the parameterization class, as you can see, that docstring has been assigned to the class. All right, to add text to describe basically describe these inputs, we need to add a text field. Okay, and to add a text field, we need to load the text class. Okay, so then type in here text. Okay, so actually it's not a text field, it's just static text. Okay, so we're not going to allow the user to change this text. It's just static text. All right, so hit enter and then type in here instruction and then say equals text, instantiate the text class, and then now in brackets type in modify the inputs and then hit enter and hit save, and then let's refresh again in our browser, and you can see that's over there. So with these kind of text, you very often want to make them prominent, right? So it's very visible to the user. So Viktor uses something called Markdown to add styling to text. So with Markdown, to add a style, to make this a more bold, you can add a hash in front of it. Okay, I'm just going to copy a hash from somewhere else. My keyboard seems to be doing something funny at the moment. So I'm going to paste that and then save. And when I've saved this and I reload the app, this text should now be capitalized, should be made bigger, as you can see. So now it's more prominent and the user knows, okay, modify the inputs below. Okay, so let's head to the sample files and copy the important files that we're going to be using in the app. So for instance, the PDF file inside the sample files, the test Dynamo file, and the computational design essay logo that I'm just going to load here. Feel free to use any other images you have on file. All right. Hello. Now head to where you've saved the sample files and let's copy a few of the files. So let's grab this GIF image, and let's grab the CDSA logo, and let's grab the CDSA PDF logo, and let's also take the test Dynamo file. Okay, so let's take those 4 files, copy. Just so you know, this test Dynamo file and the input Dynamo file are actually the same thing. We just used this first one for the worker test we did previously. This test Dynamo file is just to be used with the app. But if you renamed this one, the input Dynamo file, to this test Dynamo file, they will work the same. Okay. All right, so just copy that, Control C, and now head to your C drive, users, your username, your Viktor apps. And so this is the app we're currently working on, test Dynamo app. And then just paste those files in here. Okay. So for the logo image, which is this, PNG image over here, we need to make a new folder for it, for all static images. And I'll show you in the docs how this works as well. So just create a new folder, right click, new folder, and call it in small letters, assets. Okay, and then move the logo into assets. Okay, so now you should have one file, which is this logo file, in your assets. All right, so the other files are fine where they are. So this file and the Dynamo file, we'll leave them in the root directory. Okay, great. So now we've added all the folders we need into our apps folder. So we can check that just using this to toggle the sidebar. And you can see that all those folders have been loaded. All right, to add static images to our parameterization, static images are great because then you can actually use them to add further description to your parameters. For instance, you can add an image that describes that this is to show exactly where the building width is, to show how the rotation works, and to just, describe your app in such a way that it helps the users use it easily for better user experience. Okay, so let's add a static image, just a computational design essay logo to the top. But to do that, there's a setting we need to first take a look at. So let's head over to the VIKTOR documentation and click on these three lines at the top left corner. Then head to Create Apps and then References and then the viktor.config.toml file. Okay, now let's head down to the assets path. So the assets path has to be specified as assets in the config.toml file. Okay, so as you can see, that is the config.toml file. And you can see our assets over here. When I open this file, you can see that CDSA logo is contained within it. So click on the viktor.config.toml file. Okay, and on the assets path, on comment this, just remove this hash and backspace, and that is all you have to do, right? So you can see now assets path is equals to assets. So when we call on this CDSA logo PNG image, it knows to head into this assets path to get the image. So just save, and then you can close. Okay, so now to add the image, we need to modify our parameterization. I'm just going to close the browser on the left, and let me just slide to over here, and then comma, and then add the image. Okay, add the image class to the boilerplate. Okay, now from here, hit enter, and then type in CDSA underscore logo, then equals image. So instantiate the image class, and then enter. As the first argument, it wants the path, so we can we can indicate like that. So add the keyword argument, and then type in here CDSA underscore logo dot PNG. You need to make sure that the file name is exactly as in the folder. As you can see there, CDSA underscore logo dot PNG. Perfect. Now add a comma, and the alignment, it has other arguments that you can add. Then align, I can say center. I found this not to really work, to be honest. And then flex, I will make 50. Okay. And that is about it. So what happens though, when you've changed the definition of your folder, right? You'll usually have to close the connection and then restart your app. I found it to work better that way. So I'm just going to hit Control C and then type in VIKTOR.CLI start. And that it should work as normal. Great, as you can see there, app is ready. Now let's head back to our environment. And I'm just going to head back to the workspace because that's also usually gives an error, and then open it again. Okay, and as you can see, we now have a logo, but that is too big for my screen. So I'm just going to reduce that. I can say maybe a flex of 40. And just refresh again. As you can see, the image size went down. Okay, we can leave it that way. So there you have it. That is, we've added image to our parameterization. We've added descriptive text to prompt the user to modify the inputs. We've added number fields, both as a regular number field and as a slider. And then we've also added a color. There are many more input types you can add, like for dates, for text fields, and a whole range for download buttons and tables and others. So feel free to take a look at the docs and experiment further. So now let us head over to the most important part of the app, which is the controller class, to add views for our PDF file, for the image, and also a 3D view that picks up on the geometry from our Dynamo file. Thank you. Hi there. Awesome. Now let's continue on to the controller class. The first thing to do is to give it a description in using docstring. And I'm going to type my first VIKTOR controller. Not particularly important, but I just like to give everything a good description, right? Feel free to rename that to whatever you want. And as you can see, when I hovered over it, it gave that a description, right? This is important when you start building your own classes and programming your own methods, and you want your users to understand what they are about. For instance, when you hover over one of these number fields here, for instance, if they were giving a description, that would be included as part of that this description you can see there, right? So it's just a good way of documenting things. All right. In the label, this is very important. You can't not have this, because when you start building more complex apps and you want to call on different entities, for instance, this app we're building here could be one entity, and you can have another entity. To be able to call on those different entities, you need to give them unique names. So I'm just going to call this here twisting power, because that's essentially what we're building. All right. And the parameterization is just asking here, what parameterization am I to use? So it's basically the parameterization on top, which is called, right, parameterization, right? So we're just assigning that to the controller. Great. Okay, so we've dealt with the arguments of the controller. Right, so now let's head down and create a method that will allow us to update the Dynamo file. Okay, so using the static method decorator type in static method. Okay, and then now underneath that, we'll define an update model method. Okay. And as an argument, we will add in the params. Okay. So, and over here, we will indicate that the output is a tuple, and in square brackets, we will say file and comma Dynamo file. Okay. But as you can see, we're getting errors here because none of these have been imported. So let's import them into our file. Okay, so let's head back up into our boilerplate. Let's minimize this parameterization so we don't have to scroll up too much. And then at the bottom here, I'm going to say from VIKTOR.core import file. Okay, so basically importing the file class, right? And at the bottom, say here from VIKTOR.external.dynamo. Okay, import Dynamo file. Okay, so this is the class that lets us deal with, obviously, Dynamo files. Okay, and as you can see there, that is still giving us an error. So we need to import tuple. All right, so above here, because it's it comes from a different, I'm just going to leave a separation because it comes from a library that's not necessarily a Viktor library. So I'm just going to type in here from typing import tuple. Okay, as you can see there, that works. So this is just indicating what we will be expecting at the end of this method, which is a tuple that contains a file, right? It contains an instance of the file class and also an instance of the Dynamo file class. All right, perfect. Let's continue with defining this method. Okay, so let's describe this method. Let's give it a doc string, and I'll hit enter because it's going to be long, and I'll type in to update the nodes of the Dynamo file with the parameters from the parameterization class. Okay, and hit enter again. So if you don't want to type all this manually, you can obviously just copy paste from the app_end.py file. Okay, and you can just follow along as we go. Okay, then I'll hit enter, and then I'll add a comment. I'll say the Dynamo file path. Okay, so here we want to then call on the Dynamo file that's in our folder. Okay, so to do that, we need to import a library called pathlib, okay, or pathlib, and we'll say from pathlib import path. Okay, so over here, make sure to indent, and let's go. Say, I'm going to say create a variable here called dyn_file_path, and that will be equals to path. Okay, so instantiate the path class, and then in brackets you type in _, file and double underscore. Okay, so this is going to allow us access the file, the parent directory of our Python file, which is this Python file we're creating. So we'll put in here .parent, which is the attribute. Okay, as you can see here, the attribute of this path. Okay, and then /, and then as a string, we'll type in test underscore Dynamo underscore file dot dyn. Very important to get the file naming correctly. So now this is basically has created the file path to our Dynamo file. This Dynamo file there, that's located within our apps folder. Okay, perfect. So now let us get the file from that path. So what we've done is just created the file. So then let's go underscore file is equals to, so that's the variable, and we'll say file. So now that's instantiating the file class, the Viktor file class. And then in here, we will type in from path. Okay, so we're creating a file from a path using the from path method. Okay, the great thing about VS Code is when you hover over words, you can see what they are. So hovering over this, I can see it's a class. Hovering over that, I can see it's a method. All right, so, and then brackets, then we'll type in here dyn file path, which is that file path. So we're getting a file using the file class, the Viktor file class. We're getting a file from that file path. Okay, and now we will say dyn file, let's go file is equals to Dynamo file, and what it expects is the file above. Okay, so if we've created an object, we've instantiated the Dynamo file class to create a Dynamo file object. All right, you can see there, and then it wants the argument, which is the file, which is that file. Perfect. So now we've gotten the Dynamo file. Actually, this has been labeled incorrectly. Let me just say here, get the Dynamo file. Perfect. Then now let's hit enter. So the next step to do now is to actually start to pick on the parameters from the Dynamo file that we would like to update. Okay, and then we'll link them to the parameterization. All right, so in comments here, we'll say update the Dynamo file with the parameters. Okay, so I'm going to do the first one, and I'm going to let you do the others. You can obviously just copy and paste from the Python file that's been provided. Okay, so then we will type in here dyn file dot update colon the method from the dyn file object. Okay, that lets us update the parameters. Okay, so then I'll in brackets here. Now let's open our Dynamo file so you can see what I'm talking about exactly. So as you can see here, this is the first parameter I would like to update, right? So this update wants the name of that node that we want to update. So we're going to take that node name precisely as it is. If it's in caps, if it's small or small letters, type it in exactly as it is. So here in quotes, I'll type in a string called width, and then it wants the value that we want to update it to. So the value we will have to get from our params. Okay, so let's take a look at what our parameterization what we named our parameterization. So the width in our parameterization is building width. Okay, so we need to take that exactly as it is. Okay, so I'm going to close this off. Okay, so then in comma, add a comma, and then type in params dot. So to access the parameters of your app, we're basically taking this here, right, which this argument that we added, which is the parameters of the whole app, right? And we're typing in dot, the dot notation, to basically then access that width parameter. Okay, so then type in building underscore width. Okay, so let me just save this, and if everything is fine, it should just say app is ready. So it means we basically should have been doing everything correctly. So do the rest, and I'll see you at the end. Okay, great. As you can see in the last one, which is for the geometry color, I added string. Okay, this is because this string value, the color field that is above in our parameterization, is not like the others, right? It doesn't necessarily give us numbers. Yeah, so what I'm doing is I'm stringifying, making it a string, basically text, so it can be fed into the string input in Dynamo, right? So, and that string input in Dynamo, I do other operations to it in a Python node that basically lets us get those string values, right? And as you can see, those string values are basically broken up into integers that can then be fed as RGB values to color our geometry. Okay, let's continue with the Python programming. All right, so enter and then comment. Let's generate the updated Dynamo file. Updated Dynamo file. Okay, and hit enter, and we'll type in input file as a variable is equals to dyn file dot generate. So there's a method called generate, right? And then we will return two values, input underscore file and dyn file. So as you can see there, what the output has to be what? The input file, okay, which is this file, okay, and then the Dynamo file is that dyn file. All right, great. So let's hit save and let's refresh our app just to make sure everything is still working. Okay. Okay, so let's refresh over here. Perfect, no errors, so awesome. Let's continue to the next step, which is to add a geometry and data view. Thank you. Hi there. So now let's add a geometry and data view to our app. So the geometry and data view will allow our app to visualize the geometry and outputs from our Dynamo file. So basically the geometry.json file and the XML file would be called upon to pick certain items, so the geometry and also some outputs. Okay, so let's proceed. So to figure out how to do this, let's take a look at the VIKTOR documentation and click on the three lines at the top left corner and head to create apps and then results and visualizations. And over here, we want 3D model. Okay, so over here, you can see the 4 types of 3D model, 3D elements you can add to your VIKTOR app. So you have geometry elements from the VIKTOR.geometry module. So VIKTOR has its own modeling tools. and also GLTF or GLB file, a 3DM file, and IFC file. Okay, so we will basically be using this method, right? And we will be using that using a geometry and data view. So feel free to read further over here just to get more context. But let's head back here and click on geometry and data view. So here from the docs, you can see that we need to import the geometry and data view, right, into our boilerplate. So let's head back to our boilerplate. Okay. And then over here, we will type in from VIKTOR dot views, essentially mimicking what we see. We'll say import geometry and data view, and not GeoJSON, geometry and data view, that one, and comma geometry and data result. So the geometry and data view class will basically be the visual elements, and the geometry and data result is basically what's going to allow that geometry to be visible in the app, right? It's getting the results of the geometry and the data. But let's just take a look at practically how this works in the app. Okay, so underneath here, type in enter. Okay, make sure it's indented one level in, so it's inside this class, this controller class. All right, and then add the decorator at geometry and data view. Okay, and open a bracket and hit enter. Okay, and within that we want to call this, let's just call it building view. You can call it whatever else you would prefer. All right, and then we hit enter, and we'll create a method called geometry and underscore data and underscore view, and in bracket we add self, and then parameters, and the keyword arguments, keyword arguments. Feel free to copy this from the sample files provided. All right, cool. So then we hit enter, and let's add a doc string to describe our method. And I'll just say here the endpoint that initiates the logic to visualize the geometry and data executed and retrieved from a Dynamo script, and hit enter. Okay, perfect. So let's just save this. So there are other arguments we actually haven't added that are mandatory. So let's just do that as well. Okay. So as you can see here, there's a thing called duration guess. Duration guess. So that keyword argument. And we're going to type in, I'm going to type in here for now 1. So I'll explain this later. And the axis to right, I'm going to call that true. Okay, let me see. I think those should be the... Okay, that is about it. So this axis to right, if you look here, so they're all described here. So it's basically saying x-axis pointing to the right in the initial view. So basically telling us where the x-axis is going to be pointing. So read through this. It just helps to describe all the keyword arguments that are part of this Geometry and DataView class. All right, but we'll come back to this later for further explanation. Okay, so now let's comment update the model. Okay, so we'll create two variables over here called input underscore file, comma, Dynamo underscore file. Okay, and equals, we will instantiate the first class we made, the first method we made, which is this update model class, update model method. Okay, so to call on it, we need to say self dot update model. Okay, and in brackets as the argument, because that method requires the params as an argument, we will then say params. All right, perfect. Then on the next line, we need to now start the process of running the analysis. Okay. All right. So then we'll say hash run the analysis. Okay. Then we'll say files equals, and in square brackets, enter, and in brackets here we'll say input dot dyn. All right, so make sure this naming is correct, right? And if you notice, the naming coincides with the config file that we added to the VIKTOR worker. So this is very important. All right, so and add a comma. Perfect. Then the next thing is to add a generic analysis. Generic underscore analysis. To explain the generic analysis is basically the point at which your application takes the input file, which we created above, that has been modified with the user input, and it sends it to the back end, which is the Dynamo Sandbox, which you've installed on a server. At the moment, we've obviously just installed it on our laptops. So it sends it to the worker takes it and sends it over to the Dynamo CLI, and then it retrieves those outputs. So this is a very critical part of the app. Okay, so let us add a generic analysis to the boilerplate. So let's head back up. Okay, and then we will add here from Viktor dot external dot generic import generic analysis. All right, so then head back down, okay, and then type in generic analysis to instantiate the class, and then enter, and then files. The first files argument would be equal to the files above, okay, which is our input file, right? Input.dyn, and then enter. Executable key is equal to Dynamo. So if you look at the config file in your where we configured the worker, you'll see that that coincides with it. So you need to make sure that's spelled correctly. And then output file names is equal to output.xml. So this is the XML file, and comma geometry. So let's spell this correctly. .json. Okay. And yeah, that is about it. Okay, so I'm just going to save this and make sure it's working correctly. Okay, all good, no errors, and then hit enter. Okay, so now let's set the analysis timeout. So comment set the analysis timeout in seconds. Okay, then hit enter, and then we'll say generic analysis dot execute. So this is the actual execution method, and the argument it wants is timeout, and I'm just going to make mine 60 seconds. So this means that if your analysis hasn't been completed in 60 seconds, the generic analysis is going to stop. So the app will stop running the analysis. So you can time your app on your own, your Dynamo app, just to see how long it typically would take, right? And then you can set that as the value. You do not want your analysis to run too long, because when you start scaling your applications, you wouldn't want your users to wait for something that is not going to work. So you need to time that, test that for yourself, and see what is the optimum amount of time to allow for. Okay, so in the next line, let us now start processing the geometry we've received from the generic analysis. So let's comment here, process the geometry. Okay, so then we'll type in here as a variable geometry file equals, then we'll type in here generic analysis dot get output file. So the get output file method, as described, allows us to get the output file. So what we want to get now is the geometry. So we'll say geometry.json. Remember to spell it correctly. And then the next argument, comma, as file, we need to say true because we want it as a file. Perfect. Right, on the next line, so on the next line, we want to get the GLB file is equals to convert. There's a method, geometry to GLB. We still need to import it into the boilerplate to GLB. But let's see how to import that. So head back to your boilerplate and then type in from Viktor. We can actually just type this underneath here, backspace, enter. I'm just going to copy this line, Control C, and hit enter and Control V. And we'll say here, import, convert geometry to GLB. Okay, so that's a all right. So that's the basically a method that allows us to do that, a function. All right. So as you can see there, convert geometry to GLB, right? And then we will add the geometry file as the input. So it's asking for what file should we convert to GLB, and we just need to input the geometry file. Great. Okay, so we're almost at the end of this. So now we need to process the numerical input. So we've processed the geometry. Now, how do we process the numerical input from our XML file? So let's comment here, say process the numerical output. Okay. And then we'll say output file is equals to generic analysis, the same as above, dot get output file, and then in brackets we'll type in output, remember to spell correctly, XML, all right, and then comma, as file must be true. Okay, we'll set the boolean there to true. Great. And then here we will type in DataGroup. This will make sense later. We will say equals to self dot convert underscore Dynamo file underscore file underscore to underscore data underscore items. Perfect. And then in brackets, it wants the Dynamo file and comma output underscore file. Okay, so we still need to create this method. We'll be creating it underneath here. So we need, this method is basically going to take the outputs, the values in an XML file, and then it will send them as a data group that will then be fed into the geometry and data view. Okay, and at the bottom, so the geometry and the data is visible in our view, we need to return a geometry and data result. Return geometry and data result, and in brackets, the first thing is our geometry file, which is we'll say geometry as the keyword argument, which is the GLB file, okay, which is that file over here. And in comma, we will then output the data group. So we'll just type in data equals to data group. Great. So now the next step, let us create the static method that converts the Dynamo file outputs to a data group. So that. Thank you. Let's go ahead to create the method that allows us to extract the data from the output.xml file. So let us use the static method decorator using @ and static method. And then now let's define using def. And let's just copy this from there. Control C, Control V. And as a first argument, let's type in input file underscore file colon Dynamo file So the Dynamo file class and then the output file, let's actually hit enter here, and so it's clearer. And then as the output file, let's hit enter and backspace, enter again, and as the output file argument underscore file colon, sorry, this is the wrong spelling, output underscore file, and we'll type in file. Okay, and then what we're expecting from this is a DataGroup. Okay. But we haven't added the DataGroup class to our boilerplate. So let's head up and look at how to do that. Okay, so we head up to our boilerplate, and then under views, just let's add it close to this one, hit enter, then from VIKTOR.views we'll import data item and comma data group. Great. Now let's head back to the bottom. Okay, cool. And then hit enter. And then in a doc string, let's describe this method. Extracts the output of the Dynamo results using the input and just enter here, input and output files. Okay, great. All right, so the next thing to do is to collect the IDs of our outputs, the particular outputs that we want to feed into our app. So the outputs we're concerned with, let's head back to our Dynamo file. The outputs we're concerned with are these two outputs. I've indicated them in pink, right? So we want the area of our surface, of the building surface, right, of this tower surface, and we want the volume. Okay, so we're basically going to call on this surface area, right, in that exact spelling and capitalization, and also the volume. Right, so let's take a look at how to do that. Okay, so I'm just going to tab in here, okay, and comment shift and hash, and let's go collect the IDs for the computational output from the Dynamo file. Okay, and then output as a variable underscore ID underscore surface underscore area. Okay, so this variable will retain the ID of that surface area output. Okay, and then I'll then say input file dot get node ID. So that's a method that allows us to get the node's ID, and I'll then type in here in the same exact type, surface area. To be safe, you could just double click here and copy and just paste. Control V. Right. And then you do the same for the next one. Okay, so just copy and paste this code, Control C, hit enter, Control V, and then ID underscore volume. And then I'll then type in here volume. Okay, let us save that. Just make sure everything is working correctly. Okay, so there are no syntax errors. Perfect. So now we've collected the IDs. Let me just explain to you what is going on in the background with these IDs, just so you understand, you get some more understanding. Okay, so let's open the navigation pane and then click on our Dynamo file. As you can see here, Dynamo in its raw code, the Dynamo file in its raw code format, when you click on it in your text editor, has each node basically has an ID. So those are the IDs we're basically calling on, right? So, and those IDs can then be used to basically pick out whatever value is associated with that particular node. So that is essentially what we're doing. Right, so I'm just going to close that. And I'll close the navigation pane again. And then hit enter and add another comment. So hash collect the numerical results from the output file using the collected IDs. Hit enter. Okay, so we're going to type in here with output file dot open binary. It needs to be open in a binary format. Okay, so that method lets us read that output file, which is the XML file, as a binary format as F, and then we'll type in here area is equals to get Dynamo result well, we haven't loaded this function into our app, so we need to head to the boilerplate, head back up to our boilerplate, okay, and then we need to add it underneath here, and I'll type in from VIKTOR dot external dot Dynamo import get Dynamo result. All right, so now we can use that to get the results from the output file. All right, so get Dynamo result, and in brackets, as a first argument, it wants the file that's been read in binary, okay, so which is F. Okay, so we type in F and then comma, the ID as the second keyword argument is equal to this variable. So you can just copy this, Control C and paste, and then enter. The next thing is the volume. We can just copy this, same format, Control V, and then type in here volume, and then get Dynamo result, and we need to replace this here with this ID. Control C and Control V. Perfect. So let's save this to make sure everything is still working correctly. All right. So now we need to create our data group, because the end goal of this method is to create a data group, right? That this method on top, which is for the geometry and data view, can then call on and get that output once it's returned. Okay, so now let's add values to a structured data group. Okay. And then we hit enter, and then as a variable we type in data underscore group, then equals data group. Okay, so I basically want to have the two items grouped together in a subgroup. So they will be grouped in a subgroup, but you'll see once we add it to the app what I mean by this. Okay, so I'm going to call this metrics group. So basically the building metrics, and equals data item. Okay, right. And then the data item expects a label, and then this label will be building metrics. You can give this a name you prefer, building values or something else. And then in comma, I'm going to give this value equals to values, and then the subgroup, comma, subgroup, the subgroup argument, I will make another data group. And then I'll hit enter. Okay, so I'll hit enter again. Actually need a comma over here. Then I'll hit enter as well. Okay, so within this data group here, I will then create data items for the area and the volume. Okay, so let's type in data item. Okay, and then the label will be equal to area, and the value will be equal to round float area. So as you saw in that Dynamo file, everything is essentially a string, right? So we need to convert the string value into an actual float. Okay, and then in comma, the suffix will be equal to meters square, and that has to be a string. And for now, let us just close this off, and we'll add the last one later. I just want you to understand what is actually happening here. Okay, and I'm just going to backspace this, and then we will finally return our data group. Okay. So we've basically created our data group, but now let's see if everything works. So let's head back to our app and then refresh. Okay. As you can see now, it's running the analysis. So, okay, we got an error. Yeah, so the error is saying the geometry result takes exactly 2 positional arguments, one given. So I can see that the error is because the ID, you can see the positional argument, sorry, the keyword argument, as you can see, the ID is spelled incorrectly over here. So that must be the error. So add another underscore here, underscore. Let's save that and try running this again. Okay. Perfect. As you can see, we got an output. Okay. And we can see our 3D view. And then when we click down here, we can see we got the area. All right. So now let's add the other outputs for volume. So all we have to do here is go in, add a comma, and hit enter. We can just copy paste this line, Control C, and paste it here. And then we type in here volume. And then the value has to be float of the volume here. And then the suffix is meter cube. Okay. All right. And then we'll hit save. So the great thing about this group is that you can really neaten up your outputs. Okay. You can have as many as you want. You could even add DOM text if you wanted. If I hit Control V, and I can just type in, just as an example, height, and then around, I literally can just remove this and then say 4,000, and then backspace meters and hit save, and then refresh. As you can see now, we have area, we have volume, and then we have height. So that height will never change because it's not actually getting any data from our Dynamo file. So I'm just going to remove that because we don't actually need it. That was just an example. Perfect. So let's take a look at how our app functions. So we've basically completed the geometry view, and we've added the parameterization. The next things to do would be to add a PDF and add an image. Okay, so let's just maximize this so that we can see how the app would actually look on a full screen. Okay, and as you can see here, the parameterization is taking up too much space, right? There's a parameter that actually lets us change that. So the 3D view can take up more space because that's pretty much what we'll be more interested in, right, to view. And let's just play with the parameters to see that they're working correctly. So we can change this color to orange. But as you can see, what happens is that immediately I change a parameter, the app starts to run again. So we can also do a setting in our app that allows us, that prevents it from running all the time, right? We change a parameter. But let's allow this to change. And as you can see there, that works. Let's change another parameter. Let's say, for instance, a building width. Let's make it about 15. Okay, and let's change that as well. And maybe we can change the floor number as well. Okay, something seems to be happening. Seems to be an error of some sort. Okay, so I'm just going to close this again, Control C, and then start the app again. VIKTOR -CLI start. And then just refresh. Perfect. So everything is still working fine. All right. So now let's just head back up to our geometry and data view. Okay, above, and then add other arguments over here. So the duration guess, if we change the duration guess to 5, I think numbers above 1, it will stop the app from running automatically. A duration guess of 1 basically means you're telling the app that it doesn't run too long, so it can basically change the inputs as you go along. But we obviously know that there's a lot of work being done by the Dynamo CLI in the backend, and so it will be annoying if every time the user changes a little thing, that takes long to change. So the best thing would be to have a button that the user can click on to then make those changes that have been added in the parameterization. So we can also add something, other arguments like the default shadow. So if you want the shadow to be shown by default in your app, you can add a Boolean for true. And you can also add the update label. So the update button that prompts the user to update the model can also be changed. So we can say update label is equals to, I'm just going to call mine update model. Okay. And then let us refresh again. Refresh the app again. And let's see what happens. So now, once the app is loaded, it won't automatically run. So now you see that update model at the bottom right corner, right? So I can basically then change as many inputs as I want. Let's say maybe I want a pink, and I want my building width to be 15, and I want my building length to be about 10, and the number of floors, I can make it 11, and then I can then update the model. Perfect. As you can see, everything is working correctly, and we also have our metrics changing over there, so that's all good. So finally, let's change the width of our parameterization. So let's head back to our Python code. Let me just enlarge this, and let's head back up here to this parameterization. It takes one argument, which is width. Let's type that in, and I'm going to make mine 35. So that's basically the width, overall width of the screen. I wanted to take up 35% of that space. Okay, I'm going to save again and head back to the app, refresh, just reload the app. And as you can see now, it's taking up less space. Okay, thank you. Now let's add a PDF and an image view. Awesome. Now let's complete our app. So I noticed an error in our parameterization. Let's just head over to the top. So this floor height, I kind of copied the same thing. So I'm just going to change it here. So we'll say the floor to floor height. Okay. And hopefully you didn't make the same mistake. And then I'm going to change the default value, because this is quite tall at the moment. I'm going to make it 2.5, and I'm going to have a step of let's see, 0.5. Let's see if that works. I'm going to save that. Okay, and then I'll head back to the app and then refresh. So if you name your parameters the same, Viktor is going to take one of them and it's not going to show both of them. All right. So now let's just update the model and make sure everything's working correctly. Awesome. Now that looks correct. And just so you know, in the 3D view, you do have the ability to show shadows. That should come in by default. I think we just need to head out of our workspace and come back in again, because we have added that as a setting. And you can also close the outputs like that, right? So you have a bigger 3D view. Okay. And now let's just head back and add our PDF and image views. Okay, so to add the PDF and image views, we need to make modifications to our boilerplate. All right, so in VIKTOR views, let's just add that underneath here. So we go from VIKTOR views, and we need to import PDFView and PDF result. Okay, and then also from VIKTOR views, let's import ImageView and image result. Great. So we've added 4 classes, and that would be about all the imports we need to do for this app. Okay. Great. So now let's head back to the bottom. Let's close our parameterization. And we can also close that and close that and also that and that. Now let's leave that open. And then at the bottom, we hit enter. Okay, leave 2 spaces. And then we can say we add the PDF view decorator at PDF view. Okay. And here it's expecting the label. So it's basically what the tab of that PDF view is going to be called. And I'll call that CDSA logo. Okay, because it's a PDF containing our logo. And duration guess, I'll set to 1. Okay. And let's define the function that will actually show the PDF. So I'm going to call it def get underscore PDF underscore view. And at the first argument, we add self, then params, and then kwargs. Okay. And a colon. And then the first thing we need to do is open our PDF file. So let's comment open the PDF file. And then the path PDF. Let's make a variable for PDF underscore path. And then as a path, we need to instantiate the path class from the path lib, and then underscore file underscore, then get the parent, right? So that is the, we get the parent here, and we add CDSA to the parent directory. We add CDSA underscore PDF underscore logo dot PDF. Okay, and then enter. Then the PDF file is equals to file dot from path, and then we'll add PDF underscore path. Great. So then let's save that. Okay. And then now let's head into, no, we actually still need to return the PDF result. So we say here, return PDF result. And then in brackets, we'll say file is equals to PDF file. Okay. So you can also, as an argument, add a URL where to basically pull the PDF from a certain location, right? So, but what we've added here is a file, which is our file above. So let's save that and see if it's actually working correctly. So let's head back to the app and refresh. Okay, as you can see here, there's the label we gave it, CDSA logo, gets loaded in. And then now we just need to wait for the logo PDF to load. And as you can see there, that is our PDF with our logo on it. Okay, so any other kind of PDF you want to load on can be loaded. As you can see, you can minimize, you can maximize, minimize, make it enlarged, and also you can download. All right. And you can also maximize it over there. Okay, great. So now let's add the image. So the image we'll be adding will be a GIF image. So let's check how that will work. Right, minimize that. So then we need to add a decorator for the image view. So at image view, enter, and then let's call this my image, image, and comma, duration guess, let's leave it as 1. Okay, and then enter, define, create underscore image underscore results. Okay, yeah, and we can say image view, and in brackets we'll say self as the first argument, and params, and then the keyword arguments. Okay, works. All right. Okay, and then let's open like we did previously for the PDF. Let's open the image file, and then the image path underscore path is equals to path brackets underscore file underscore dot parent. So that is for the parent directory, and we add the name of the image. So that is, the image is called give you underscore up dot gif. Okay, so we can see there in our navigation, you see there give you up, and also the logo PDF is that. So you see they're named exactly the same. All right, so now let's get the file from, let's get the image. Okay, so we can just return this actually. And we can say image result dot from underscore path. Okay, and then we just need to type in here the image path. Okay, and that should be working correctly now. Okay, so now let's go check our app. So let's refresh that. And as you can see here, the image has been loaded. Yeah, let's let it load. And there we go. Yeah, and you can zoom in and out of the image. So if you wanted, you can't add video to VIKTOR, but if you wanted something that has some motion, you can also do that. So we've got our PDF as well, and we've also got our 3D view. Update our model. And that's about it. Hello. Let's assume this is an app that you're proud of. You're ready to share with your users. You're ready to share with people in your office because you think it's going to solve a lot of problems and you think there's value in the app. Okay. The way to start sharing that with the app, I'm sure you've guessed it, is to publish the app on the VIKTOR platform. Right. And guess what? This process is actually quite simple. So we'll go through the steps and publish the app, and that will be done. Okay. So you can check out the VIKTOR documentation. Head over to Publish Apps. And over here, you will see a tutorial just explaining the process very simply. Yeah, you can read this as well. But for this tutorial, let's get into it as well. Let's go in more in depth. All right, so head into Workspaces, to your Workspaces on VIKTOR, then the App Store, and then Create App. So let's give the app a name. I'll call mine Twisting Tower Configurator, and a short description, an app that creates twisting towers. An example of a long description. But obviously, you can make this much longer because you have 500 characters. Okay, so now let's hit Next and add app labels. So what is your app related to? So if you want your users to be able to easily find the app and categorize your app, you need to say what industry, for instance. So is it an architecture app? So this one is architectural. Is it a BIM app? Kind of. Is it a Dynamo app? Yes, it is. Is it, what else is it? So try and find all the things that it's related to. All right. So then we head over to App Images. And then this is the icon for the app. So make sure you choose an image that captures the essence of the app. So then we head over here to Choose File. And I'm just going to pick that red image. And then it wants us to upload at least 1 and up to 5 images of the app. Okay, so we can add more images. So let's choose one. All right. I'm going to choose that one. I'm going to choose that one as well. And then now it wants to give us, it wants to use a default cover. Okay, so I'm just going to remove this default cover. And then I'm going to add another image that's much bigger. And I'm not particularly sure which one's going to use as the cover, but let's take a look. We can always come back. Then let's hit Next. And then who's going to maintain this app? So I'm the only one in my development environment. I'm working on this development in this workspace. So I'm just going to leave myself over there. And then next we'll review and create. As you can see, it's not using the larger image. So what I'm going to do is actually head back, go back, previous and previous. I'll change this to this blue one, and then I'll remove this one, remove, and then add the others at the back. Okay, so that one, and add another one. Okay, so I think we can just leave it like that. Okay, there we go. As you can see, the more clear image is shown. Okay, perfect. So now we can hit Create. And as you can see here, we've created the app, but we haven't yet published the app code to the platform. Great. Now let's see how to do that. Hello. Head back to your text editor. And in the CLI, if your app is still open, just hit Ctrl+C to close the connection. And now let's type in the command VIKTOR -CLI apps. Okay, so this will basically list all the apps you have on Viktor, right? So as you can see, we just created this twisting tower configurator, and that's why it's showing over here in the terminal. So if you haven't created an app, it's not going to be listed. Okay, so now we can basically use this name, right, to publish the app on the Viktor Cloud. Okay, so to publish the app, let us take a look at the command we need. Okay, so let's head to the docs, and then here, we can see on the publish Viktor apps, the page we opened previously, you can see here that this is the command to publish your app. So we can just copy that code, okay, and then head back to our text editor and paste that in the terminal. And we need here to edit this name. We need to give that our app name. Okay. Great. So over here, I'm going to type in twisting dash tower dash configurator. So just check that the spelling is correct. And before we actually publish it, let us head over to the requirements folder. So this requirements basically lists in here, you list any external libraries, any Python libraries that your app is dependent on. If you do not do this, you're going to have to republish your app, right? Because if you, for instance, used a library like pandas, right, and pandas is not listed as part of the requirements, the app won't work because the requirement library, the library that's required, which is pandas, was not published with the app. Okay, I hope you understand that. So that's one important thing to make sure you check. All right, so and then the versioning over here is basically, this is our first version, so we can leave it like this. So all we have to do now is hit enter. And yes, so it's basically telling us the following will be published as part of our app, and you're just checking everything to make sure it's all good. And then do you want to continue? Hit Y and then say enter. So as you can see, the process is ongoing. So this, if your app is a very heavy app, this one shouldn't take too long. You know, publishing all the libraries might take a while, but feel free to pause the video and come back when it's all done. Perfect. The app has been successfully published. Now let's head back to the VIKTOR workspace to take a look. In your VIKTOR workspace, head to App Store, and now you can see our published app over here. Okay, so on the app, click Create Workspace, and we search for the apps we have available, and we click on this one, Twisting Tower Configurator, and hit Next. And I'm just going to call this Twisting Tower. So the workspace is where people will basically have access to the app, right? So you can publish more versions of the app to that same workspace. So even when the app version changes, the users still get access to pretty much the updated version of the app. They never lose access to the app. All right, so I'm just going to give it a description the same description, an app that creates twisting towers, and I'll hit next. Workspace details, keep the same details. Workspace image, I'll choose this image. Okay. Workspace visibility and access. For this, because we're using the editor type app, which is the free app, right? We will only be able to give it a public access. So this means that this app can be used by anyone with a link, right? So you won't be able to control it being a public or private app. Okay, then review and confirm. Yes, I'm happy with this. Then you just click on create. So now in your workspaces, you're not just going to have the development workspace. Now you have an app shown in the view as well. And at the top right corner, you'll be able to see how many times people have viewed your app. So let's open the app. So as you can see now, the app is over here. Even if even if I head back to our terminal, you can see there's no connection between our app and the Viktor platform. But if we went back to our workspace and we actually clicked on our development environment, you will see that there's nothing coming up, right? It's going to lead to an error at some point. All right, but the app can now work independently, right? So there's one thing, though, which I have alluded to, is that for the app to run truly independently, you need to make sure that there is a worker on a server, a virtual machine, hosted on premise in your office or on the cloud. So the cloud hosting is the preferred option, because the latency between the Viktor cloud and the cloud and other cloud platform is most likely much less, right, than if it was in your office. So that is the speed at which the information gets transferred between both platforms. So unless your laptop is going to be constantly on for users to make use of the app, it is not really recommended that you only have this one worker, which is on your computer as the primary worker, right? So this is something to consider. But other than that, the app will work. Sorry, this is the app here. So if I change this to yellow and I change the building height, the floor height, floor number, let's see this. Okay, yeah, I know why something went wrong. So let's take a look at the worker here. Okay, so we need to edit this, edit worker, and make sure that our app is added as a workspace for it to work on, right? So this is another important detail. So I'm going to save that. And then now when I head back to the app and I refresh, okay, and I change the parameters, and let's change the color as well, and I update the model, and you can see it didn't lead to the error quickly, which means it's actually using that worker. So let's wait for the result, and then we can end off the tutorial. If you liked the content, you liked the video, you liked how in-depth it was, please let us know in the description. If you want more of these sort of tutorials, let us know. What other platform would you like us to take a look at? What didn't you like about the tutorial? Please also like and subscribe. That helps the channel a lot. Thank you for watching, and see you at the next one. Cheers.